These are two magnets. Like poles repel, opposite poles attract. If you slide one magnet onto an iron rod and let the other magnet pull it, the magnet will start to rotate, but it can only turn half a circle. Once opposite poles meet, they snap together and stop. To keep it moving, you rotate the second magnet. Using magnetic repulsion, you force the first one to turn another half circle. Now let's upgrade. Take a metal bolt, wrap it with copper wire and run an electric current through it. According to electromagnetic principles you learned in school, the coil generates a magnetic field. Reverse the current and the magnetic field reverses too. Fix two permanent magnets on both sides of this electromagnet, because like poles repel, the electromagnet rotates half a turn. Swap the wires, the magnetic field flips and it rotates another half turn. If your hands are fast enough, switching wires non-stop, the electromagnet will keep spinning. But obviously, that's exhausting. So you get smarter. You simplify the coil into a square metal loop, also called an armature. You reshape the side magnets into curved forms. At the connection point, you install two curved metal plates. Then you press two carbon brushes against them with springs. You fix the positive current to the left brush. When the armature rotates half a turn, the contact switches sides. The current direction reverses automatically. The magnetic field flips, and the armature keeps spinning. But with only one loop, rotation is jerky and uneven. So you increase the number of armature loops in metal segments to 16. Now the rotation becomes smooth and continuous. Refine those loops into many thin copper wires. Add an iron core at the center. Congratulations, you've just invented the brushed motor. It's named after the two brushes that conduct current and switch polarity, but it has problems. Brush friction creates noise, sparks and wear, and the brushes need regular replacement. So once again you change your approach. You fix two permanent magnets to the inside of a rotating disc. Then you place an electromagnet at the center. Power it on, and the magnets are pulled into motion. But there's a problem. At certain positions the rotor stalls. To keep it spinning, the magnetic field must switch at exactly the right moment. Manual switching is unstable. Sometimes the rotor even spins backward. So you upgrade again. You replace the iron rod with a triangular coil structure, wrap it with wire, and connect it to an electronic controller. You install sensors at each corner. Now watch what happens. When the S-pole magnet is pushed and pulled by the electromagnets N and S poles, it rotates forward. As soon as it reaches the next position, the sensor detects it instantly. The controller cuts power, switches the magnetic field and reactivates the next coil. Behind the magnet is now the same pole pushing it forward. In front is the opposite pole pulling it in. Repulsion and attraction work together. The magnet keeps rotating, again and again, faster and faster. Congratulations, you've just invented the brushless motor.